Hey YouTube, I am Leo with Remodeling Calculator, and we just finished installing my 15.4 kilowatt solar array, solar system. So I will show you in this video the whole installation process, and I will also talk about why I chose to go with these panels, with this company that installed it, why I hired the company instead of doing it myself. I mean, I'm a roofer after all with solar training, so there's a lot of things to cover. The basics of the system is these are 350 watt LG panels with power optimizers and a 10 kilowatt inverter by Solar Edge. So two things, why is it a 10 kilowatt inverter and 15 kilowatts of solar? Basically in Massachusetts our net metering laws are really weird, where the maximum we can have for net metering is 10 kilowatt inverter. Okay, the solar panel size doesn't really matter. I could have 100 kilowatts here, but the maximum inverter size should be 10 kilowatts. Otherwise I lose 40% of my net metering credit. So for example, I'm getting paid about 20 cents per kilowatt hour under 10 kilowatt inverter size. If I go 1 watt over that, I lose 40%, so they're paying at 60% rate, and that's on the whole amount. Okay, so it made no sense for me to go over 10 kilowatt inverter, and I put a string inverter. And basically in the winter, when there's the sun is lower, there's fewer hours, I will generate the full 10 kilowatt on a good sunny day, maybe a little bit less because there's some shading on the system, but it's gonna be nice. In the summer, where there will be clipping, I will be losing some, but again, this is nominal 15.4 kilowatts, so like with the efficiency loss and the inversion, it's about 12 kilowatts, so I'm not losing that much, and that's only during the peak hours where there will be clippings. For the rest of the day I will be maximizing that inverter size. Okay, and so this has power optimizers. Each panel has its own power optimizer, and the way that works is if a panel is shaded or partially shaded, the whole array does not get knocked out or lose a lot of efficiency. So only that panel that's shaded currently, that's the one that's losing production. Okay, and you will see in the installation video how the shading moves, how when the sun gets up, first the roof is completely shaded, and then like the sun moves and starts shining on the left side, on my left, on your right, and just moves, and then the whole roof is in sun. Okay, so I hired a local company to install these panels, and a lot of you will have a question, how much did I pay? I paid $2.65 per watt installed, and on top of that I have a generator attachment, generator connection, so that cost me $450. And I also have a power monitoring unit installed for $350. Okay, so about $41,000 total. Okay, so here are the panels in the close-up. There's 44 panels, 350 watts each. So you'll notice this is a little ugly, but that's the way it's gonna be, because basically my roof, if you watch my other videos, it's basically post and beam, and so this is a beam going up, and they're spaced about 8 feet apart. So the next mount to the roof is somewhere over here, and then the last one is somewhere over here. And so the engineer basically said that we have to put all the roof mounts into the beams, not into the roof sheeting, although it's a 2x4 board, I mean 2x6 tongue and groove board. This is the way they did it, so those rails extend out a little bit, kind of ugly. There's a couple more on the up over there on the top. I was hoping to get another panel in there, but there's just like a couple of inches where it doesn't fit next to the chimney. Okay, so the electrical connection is done under the panels, and then there's this box over there. Hope you can see it there, right there, the pancake box. So all the wires go inside of that box from the bottom. You can see it there, and they come out over here through the roof. The box goes under shingles, so it's like a standard roof vent, only low profile, and just all the wires go in here and go into my inverter. Okay, so here is the Solar Edge inverter, and this is again a 10 kilowatt DC or AC, I think it's 10 kilowatt AC string inverter. So all the panels are connected to this inverter, and if inverter dies I will have no solar. And so the DC power at up to 400 volts, 480 volts right here, comes in here, gets converted to AC power, comes out at 240, goes over there, and I'll show you connection to the panel. Okay, so the power comes in through this pipe right here and goes into this disconnect box. Later we will add on a smart meter over here that will measure the production of the solar panel, and a bi-directional meter that will measure how much power I send back to the grid and how much power comes from the grid to my house. Now I'll talk about production later, but I will not, even with a 15 kilowatt system, I will still be short a little bit of the power production that I actually need. And the reason for that is I will be using all of my power for heat pumps, which do air conditioning and heating, and they are super efficient. However, I will do the whole house with them, so I will be short about 10-15% of the power production of that unit. Okay, and I also do a little bit of Ethereum mining on the side, so that also eats a little bit of power. So let me show you the mini splits. And so here are my mini splits. This is one cluster of them. Okay, so these, they already work, the small ones. This one is hitting my whole addition right over here, 600 square feet, 2 stories. So it's doing a great job heating it. It's a 9,000 BTU unit with a 22,000 BTUs of heating capacity, and it's super efficient. You can see 33 SEER on the AC side and 14 HSPF on the heating side. Okay, that's I haven't really seen a more efficient unit outside of that what I call a fake carrier. So the carrier calls it a 40 SEER air conditioner, but I have high doubts about it. I mean, it's insane. Anyway, so this one is heating one of the bedrooms, and at some point the house is, it's not huge, but you know, there's a lot of smaller rooms, so I decided I don't want to have like 7 or 8 of those single zone units. So I installed this big boy right here. This is a 4-zone. Okay, and I actually made a video how I built this platform, how I installed the stand. So the reason for the stand, I mean, it doesn't look super pretty, but in a winter, all the snow that will accumulate here, if it gets to this point, it might start freezing over, and then my heating efficiency will drop substantially. And also there will be some condensation which will melt off during defrost cycles and will have to drain through the bottom. So I need clearance on the bottom. That's why I put it on a 2-foot stand. Okay, so this is a 36,000 BTU unit, 4 zones. Here are the zones, zone valves, so I'm going to be installing those very soon. I just haven't gotten to it. And here are the efficiency ratings. So it's actually a 20 SEER. The 18 SEER is for ducted cassette, but unducted it's 20 SEER and 10.3 HSPF, which is substantially lower than that unit over there. But the bigger these guys get, the more efficiency they lose. Okay, and so it requires a 40 amp breaker, as you can see over here. Hopefully you can see it. But it's rated to run at 26 amps in the heating mode, okay, and the 20 amps in a cooling mode, and that's when the whole unit is running. Now you can, this is a modulating inverter compressor, so you can run at very low production. I think the minimum is like 6,000 BTUs, and it can ramp up to 36,000 in the AC, and I believe it's about 40,000 in the heating mode. And finally I have 2 more units here. They're slightly different. That's a 33.1 SEER because it is the latest generation, but this one is 33 SEER, and they're almost identical. So it's 0.1 SEER difference. This one is almost never on. It's for the sunroom, and that one is heating my living space right now, which is about 800 square feet, open floor plan. So this 9,000 BTU unit is heating that, and it's doing a pretty good job. So I've made a bunch of videos, and I'll publish many more of them showing how to install all of these systems, walking through every step. And I know it doesn't look pretty because I just don't have time to finish all this, you know, the nice looking things, to put a line height in there. I'll get to it at some point, but the point is that they're working great. And you see this is running. I'll actually show you how much power it's using right now. Okay, so here's my Emporia app. So this is heat pump living area, and it's using 1,000 watts, and I just cranked up a little bit. So if we go by the minute, it's staying about 800 watts range, and you know, goes up and down a little bit. And at night when it was super cold, and I actually put it on 88 and on high fan speed, so the fan speed actually changes how much heat is being transferred into the house, and therefore the compressor needs to work harder to bring more hot gas, hot refrigerant inside the unit. So it's not just the fan speed, but it actually extracts more heat from the refrigerant, therefore compressor needs to work harder. And then went up to 2,000 watts, up to 2 kilowatts. Okay, but think about it, your space heater is 1,500 watts and it doesn't really do anything. Yeah, anyway, so I'll have a whole video explaining how efficient these units are, And let me just show you what it's set at. So here's my control app from Fujitsu. And in the beginning it was kind of annoying, but it's getting better. Okay, so this is the only unit that's working right now. Let's take a look. It's set to 78. And if I refresh this, it will show the temperature inside. I think it's like 76. But again, the temperature sensor on the unit is up on at the top of the unit, at the top of the ceiling. Ah, it's taking forever. Okay, 76, like I said. Like, they are super efficient. They're super quiet. You can hear, like, so you can hear better. I can barely hear it. Okay, so in this video, once again, I'll show you the installation process for somebody it might be interesting, but I'll talk about exactly how much power I will need to run all this heating equipment. Okay, so basically, once I have the power company do the final inspection and turn on the system, I will start producing some electricity. Again, in the winter the production is not as good as in the summer. However, with an array being much bigger than the inverter size, I think we're going to maximize the winter production as well. And my idea is to have a free heating and cooling for the rest of my life. Now, in this case, it's not going to work because I think my load is a little bit higher than this system can produce. However, if you live in a state where there is no such limitations on net metering, where you have to be limited by 10 kilowatt inverter, which is stupid, but hey, that's how the business runs. You could actually put like 20 kilowatt solar system, and for most homes, you can heat and cool your house with mini splits like that one over there. And in the end of the day, after you recoup the initial investment in the system, it will be free. my system should pay for itself in 3 to 4 years, maybe 5. So think about it. My gas bill was about $600 last year, a month, during the coldest months, and about $350 to $400 during like the beginning of the winter and the beginning of the spring. So about $450, $500 a month I was paying for gas. And then they just announced a 20% gas price increase in Massachusetts, which would make it about $600 a month. And on top of that, I was also running the heat pumps because my addition, the one over there, does not get any heat from the furnace. Because it's an addition, it was an afterthought, and they just basically tied it in into existing duct. There is no heat going in. That space is always 15 degrees lower than the rest of the house, and it's like unlivable. It's like when we set it for 70, it's 55 in the addition. You can't sleep in there, it's too cold. So I will have free heating and free air conditioning for the rest of my life in this house, and then I can sell it to somebody if I decide to move, and they'll have a free free heating and free air conditioning. After 5 years maximum, the system will pay for itself. Now remember, there is a 26% tax credit from the federal government. There's $1,000 from the state, and then I'm going to be getting solar renewable energy credits, whatever they call it now. That's going to be about $1,000 a year. So within 4 or 5 years, within 5 years, I get $5 grand just in the solar energy credits, or RECs, renewable energy credits. And all the savings that I have on the electricity during the whole year, during the winter and during the summer, this should pay for itself within 4 or 5 years. Maybe even faster. I'll do all the math. And that's enough mumbling and talking. Let's begin watching how the guys installed it. And the company that I used to install it is called Second Generation Energy, SGE Solar. I'll link them in the description below if you guys are interested. Now they're in eastern Massachusetts, so if you're in other parts, tough luck. But I'm sure you have great installers in your area also. So the system was approved by the local building and electrical department on the first try. They did a really good job, and let's watch how they did it. So here is a video from the first day of installation, and the first crew that arrived, they were not electricians, they were more like roofers or climbers. So basically their job was to install rack mounting hardware and rails, and the electricians have finished the job. So basically this crew on the second day, which I don't have a recording of, they installed 2 rows of rails. However, because the mounts are about 8 feet apart and there were splices between the mounts, I asked the electrician crew to reinstall the first 2 rows and to have it more sturdy, which they did. Alright, so here are the power optimizers. Now, again, these are not inverters, these are not microinverters, these are optimizers, and then we have a primary inverter that big boy over there. That's a 10 kilowatt inverter. There's 15 kilowatts of solar here, and so the reason for this is because, like, while it will peak in the summer, in the winter it will produce more because the inverter allows for it, so it will be closer to the maximum, and this way overall production will be higher. Well, it will be clipped in the summer because of there's more solar than the inverter can, convert, but in the winter the production will be higher, and this will compensate for the clipping in the summer. Okay, the reason we went with the 10 kilowatt and not bigger, because stupid Massachusetts laws, or in the net metering laws, they only allow for maximum of a 10 kilowatt inverter, and after that you lose basically 40% of your net metering credit on the whole amount of kilowatts that you produce, not just the whatever is over the 10 kilowatts. You basically lose 40% on everything, and so it just doesn't make sense. Yeah, solar friendly state. So those are LG all black 350 watt panels. The reason we went with 350 and like not 360, not 365 is because of the inverter limitations, and also the layout of the roof, which has like a skylight in the middle. So that was kind of a limitation. There is no video from the second day when they installed these two rows right here. And this is the electrician crews. And on the second day, what they basically did was run some wiring and install the inverter, which you cannot see because it's around the corner on the front. And they installed the pancake mount on the left bottom corner of the roof, through which all the wires from the solar panels go into the inverter. So it's a true roof mount, which is watertight, and it allows all the wires to go in there and avoid any potential roof leaks. And after that they just left because they needed a longer day to install the rest of the rails, which they did on day number 3. So here you will see the electrician crew, Patrick and his brother. They're fixing the rails for me. They'll also install additional mounts that will not go into the beam on the edge of the roof, just for additional security, which is a nice addition. It wasn't originally discussed, so it's an upgrade. And you can see they're installing the rest of the rails on the day 3 or 4 at this point. Doesn't really matter. So, and once they install all the mounts, they'll have a building inspector come out, inspect the job, approve it, after which they'll start installing all the solar panels. Also on this day they installed all the grounding wires for each array that they run, and it is very important in case there is like a lightning or something, or a short, you want your system to be grounded. And finally now they're installing the power optimizers in a location of each solar panel. So there's 44 solar panels and there's 44 power optimizers, and those are the small white or gray boxes that are hanging on the top rail of each row. So each row is 2 rails, and so on the top they hang the optimizer box, and then all the panels get connected to optimizer boxes. And you can see the shade on the roof, and so what happens is optimizers, they instead of cutting out the whole array, they just cut out the panel that's being shaded, which improves the solar production. Here is a close-up look at that additional mount on each rail, and also at the power optimizers, how they're installed. And again, so each solar panel will use those MC4 connectors. One is negative, one is positive, and they'll all get clicked into the optimizer and form the strings. I believe there's 2 strings in here, but I'll have to calculate it, because again the inverter is 480 volts, maybe there is more than 2 strings. Alright guys, so we have 12 panels installed already, and we have 32 more over there. So this morning the building inspector approved the permit for the for all the railings, and the crew started installing the panels. So these are 350 watt LG panels, 60 cells. So not the highest efficiency, you can get them in 370, but then we would be over limit on our inverter. And the way that Eversource works, Eversource is my company, actually the way that solar net metering works in Massachusetts is you're limited by 10,000 watt inverter, 10 kilowatt inverter. And if you go over 10 kilowatts, then you basically lose 40% of your total net metering credit. So your, for example, our credit is about 20 cents per kilowatt. But if we went over 10 kilowatts on the inverter, then we would be getting like 12 cents per kilowatt hour instead of 20. And that's on the whole amount, not like, you know, wattage over 10 kilowatts. It would be for the whole amount. So it would completely not make sense. So we limited it by 10 kilowatt inverter, a solar edge. Let me show you. So there's our inverter. There's the pipe going to the roof over there. And there is a through roof pancake cover, I guess, that allows the wires to come in without without there being any holes in the actual roof. So it completely covers the roof from the hole in the roof from being exposed. Here's our inverter. It's a string inverter, and the system has optimizers, and we opted to not go with the mini inverters because then it would be a problem with the 10 kilowatts thing. So yeah, here's the wire for the Ethernet right there, and it's connected to the router right above that, right at the top of the window. I have my wireless T-Mobile router, 5G router for home internet. But yeah, anyway, so we'll continue with the rest of the installation when the guys come back. I think they went to lunch. This is day number 4 or 5 of the installation, and on this day the guys installed 12 panels at the bottom left corner, and after that they left. Probably had something to do, or the day was getting short and they didn't have enough time to finish the system. So they will finish the system on day number 6, installing 11 kilowatts in one day. Or they just took oh, they had to bring all the panels up, which takes a long time because the panels are at the bottom of the driveway, so you gotta bring them all the way to the location. And so once they load them all up, they'll start putting them on the roof. And you can see how the shading is actually slowly moving, and by about 11 o'clock the roof is fully in the sun. There's still some trees and a little bit of shading, but this is mid-November, so by the time summer comes around the roof is in the complete sun all the time, except for the last couple hours in the evening, like after 5-6 p.m. The bottom left corner where they're working right now gets shaded, but otherwise the whole day the sun just like shining on this roof and the electricity is pouring in. I can't wait for them to enable the system for the Eversource to do their inspection and turn it on. Again, on the bottom left side you can see my mini split air conditioners, which are great for heating. Right, this is the final day of installation. In one day guys will install 11 kilowatts of solar panels, so that's I believe 32 panels that they'll install in one day. Cut and trim all those rails that stick over the roof edge. So once they do it, that's when they cut it, after they install the panel. And I am actually very surprised how they keep everything so even and so lined up. It's amazing, because if I was doing it, my panels would be off here and there by you know, quarter inch, but over a span of several panels everything gets out of whack. But these guys, they're amazing. Every panel is lined up in straight lines, all the rails are lined up. Like, sure, they used the chalk lines before they installed all the rails, but still everything lines up perfectly, like vertical spacing, horizontal spacing, top, bottom, left, right. It's amazing. Everything is very clean. So great job, and I'm very happy. Can't wait for Eversource to finally inspect this, give the final approval, and turn the system on. So I'll start making free electricity. Thank you for watching. I hope you found it interesting and informational, and hopefully it answered some of your questions. Now, if you do have questions, ask them in the comment section below. Please click like button if you enjoyed it, subscribe to the channel, and I will be posting more videos about the production, about the installation of all those heat pumps, as well as the total energy consumption of heat pumps and how efficient they are. See ya!